how far could this idea be taken? Papin was in no doubt. This is an extract from his letter to Leibniz. I can assure you that the more I go forward, the more I find reason to think highly of this invention, which in theory may augment the powers of man to infinity. But in practice, I believe I can say without exaggeration that one man by this means will be able to do as much as 100 others can do without it. Now, you might expect me at this point to tell you that Leibniz and Papin changed the world forever. Well, they hadn't. Their ideas had been profound and far-reaching, yes, but they hadn't really moved things forward. For that, you need something much more tangible. You need innovation, industry. You need countless skilled workers and craftsmen who are going to apply these ideas, to experiment with them in novel and new ways. Well, in the century that followed Leibniz and Papin, this would take place in the most dramatic way imaginable.
Peter? The files from the rotors.
Ja, dat zit in de Ēngines of Ēternity performance tot design as well. Dus in de laatste toegevoegd
150 years after Leibniz and Papin's discussions, the living force had been harnessed in spectacular ways. The machines they dreamed of had become a reality. Steam engines were now the cutting edge of 19th century technology.
If you look at steps in civilization, then one great step was the steam engine, because it replaced muscle, animal muscle, including our muscle, by steam power. And the steam power was effectively limitless and hugely important to doing almost unimaginable things.
But steam technology would do more than just transform human society. It would uncover the truth about what Leibniz had called the living force and reveal new insights about the workings of our universe.
This is across the Ness in South East London. It's an incredible industrial cathedral and holds some of the most impressive Victorian steam engines ever built. Constructed in 1854, Cross Nest houses 4 huge engines that once required 5,000 tons of coal each year to drive their 47-ton beams. Everything about this place seems to have been built to impress. From the lavish ironwork, the grand pillars like something out of a Greek or Roman temple.
It's the sort of effort you think would have been lavished on a luxury ocean liner for the rich and famous. And yet this place was built to process sewage. Although only a few workers and engineers would have seen the insides of this place, steam had become such a vital part of British power and economic prosperity that it was afforded almost religious respect. But for all the great success and immense power the engines were bestowing on their creators, there was still a great deal of confusion and mystery surrounding exactly how and why they worked. In particular, questions like how efficient could they be made? Were there limits to their power? Ultimately, people wanted to know just what might it be possible to achieve with steam.
So if the materials that are made are very beautiful, so I mean the assembly, but those are sharp. Yeah, exactly. So assembly is very
The reason these questions persisted was simple. Almost no one had understood the fundamental nature of the steam engine. Very few were aware of the cosmic principle which underpinned it.
these great lumbering machines that we think of as the early steam engines actually were the seed of understanding of everything that goes on in the universe.
I thought you were laughing with me.
As unlikely as it sounds, steam
I thought you were
engines
just messing with me.
held
I'm
within
stripping, to be honest, so it's a bit difficult.
I can see why.
the secrets
Meant
of
that
the
everything
cosmos.
I didn't want to use this name. Yes. But tomorrow we cannot go in that situation.
This is the Chateau de Vincennes in Paris. Events here would motivate one man's journey to uncover the cosmic truth about the steam engine and help to create a new science. The science of heat and motion. Thermodynamics. In March 1814, during the Napoleonic Wars, when Napoleon and his armies were fighting elsewhere, Paris itself came under sustained attack from the combined forces of Russia, Prussia, and Austria. And citizens of the city were deployed around key locations to protect them. Now, this chateau was being defended by a group of inexperienced young students who were forced to retreat under sustained artillery fire. One of them was a brilliant young scientist and soldier. His name was Nicola Leonardi Carno, and the humiliation he felt personally would drive him and motivate him to uncover a profound insight into how all engines work. Carno came from a highly respected military family. After the French defeat here and elsewhere around Europe, he became determined to reclaim French pride. What really bothered Carnot was the technological superiority that France's enemies seemed to possess. And Britain in particular had this huge advantage, both militarily and economically, because of its mastery of steam power. So Carnot vowed to really try and understand how steam engines work and use that knowledge for the benefit of France.
He says absolutely explicitly that if you could take away steam engines from Britain, then the British Empire would collapse. And he's writing in the wake of French military defeat, and he proposes to analyse, literally, the source of British power by analysing the way in which fire and heat engines work.
Living on half pay with his brother Hippolyte in a small apartment in Paris, in 1824, Carnot wrote the now legendary way in which all heat engines work. Carnot saw that all heat engines comprised of a hot source in cooler surroundings. Now Carnot believed that heat was some kind of substance and just like to do useful work. Carnot's crucial insight was to show that to make any heat engine more efficient, all you had to do was to increase the difference in temperature between the heat source and the cooler surroundings. This idea has guided engineers for 200 years. Ultimately, jet engines are more efficient still, thanks to the incredible temperatures they can run at. Carnot had revealed that heat engines weren't just a clever invention. They were tapping into a deeper property of nature. They were exploiting the flow of energy between hot and cold. Carnot had glimpsed the true nature of heat engines, and in the process begun a new branch of science. But he would never see the impact his idea would have on the world. In 1832, a cholera epidemic spread through Paris. It was so severe it would kill almost 19,000 people. Now, back then there was no real scientific understanding of how the disease spread, so it must have been terrifying. Carnot, undaunted by the risks, decided to study and document the spread of the disease. But unfortunately, he contracted it himself and was dead a day later. He was just 36 years old. A lot of his precious scientific papers were burned to stop the spread of contagion, and his ideas fell into temporary obscurity. It seems the world wasn't quite ready for Carnot. Carnot had made the first great contribution to the science of thermodynamics. But as the 19th century progressed, the study of heat, motion and energy began to grip the wider scientific community. Soon, it was realized that these ideas could do much more than simply explain how heat engines worked. Just as Linus had suspected with his notion of living force, these ideas were applicable on a much grander scale. By the mid-19th century, scientists and engineers had worked out very precisely how different forms of energy relate to each other. They measured how much of a particular kind of energy is needed to make a certain amount of a different kind. Let me give you an example. The amount of energy needed to heat 30 milliliters of water by 1 degree centigrade is the same as the amount of energy needed to lift this 12.5 kilogram weight by 1 meter. The deeper point here that people realized was that although mechanical work and heat may seem very different, they are in fact both facets of the same thing.
When I first got the call that I had an offer from
KL is proving to be a loyal ally to David. And David is going to need him more than ever. By rare coincidence, 3 of the 7 females have become sexually receptive at the same time. Their swellings attract the attention of all the males. The females will try to mate with as many males as possible. David must control them all to ensure that he is the one who mates. But some of the troop
is a star. Some passing just a few billion miles from the event horizon. A hair's breadth on galactic scales. These flybys could have fatal consequences. Some of these stars will likely have planets in orbit. Planets that may stray too close to the beast. A moth to a flame, pulled from its parent star towards the abyss. If the planet survives its journey inwards, and we could stand on its surface and look out into the universe beyond. We would see space and time becoming increasingly distorted. But eventually, tidal gravitational forces become too strong. Inexorably, the singularity awaits. The end of time, where all paths terminate.
Functions. Color.
Heerlijke fruitsla met verse ananas, appeltjes en een toets van... Lekker! Niemand is perfect, zo wat? Doe gewoon wat perfect is voor u en uw gezin met Lidl. Lidl, voor iedereen die telt.
Time-lapse of the future. Yeah.
The extra heat this generates will cause its outer layers to expand. The sun is now dead. Its remains slowly cooling in the freezing temperatures of deep space. The fate of the sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night.
All stars eventually will run out of fuel. The temperature of the universe drops. The stars, one by one, in the night sky will turn off. And there'll be no more new stars created. And so that the universe will end not with a bang, but with a whimper. And not in fire, but in ice.
With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. Will provide the only illumination in a dark, empty void littered with dead stars and black holes.
In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future.
A black dwarf will be the final fate of those last stars. White dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter. Little more than the ashes of stars. Their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun. Stars take so long to reach this point. We believe there are currently no black dwarfs in the universe.
We have a pace of life that's based on really the energy available to us now. You could imagine living conscious systems which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal. Even if our life dies out, one could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence.
Proton, one of the fundamental building blocks of atomic matter, of what makes us up, can just spontaneously fall apart.
Any material that evades the pull of a black hole eventually dies away as its protons disintegrate.
matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light and black holes. The arrow of time creates a bright window on the universe's adolescence, during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life as we know it is only possible for 1,000th of a billion billion billionth billion billion billionth billion billion billionth of a percent.
Black holes become the fundamental building block of the universe. A galaxy will basically be a supermassive black hole in a center with smaller black holes orbiting.
Zombie galaxies filled with black holes continue to evolve.
They'll lead each other and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales we're talking about are now trillions of years instead of thousands or millions of years.
Space-time like mallets on a drum. and they have a very characteristic song. Imagine two black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time. And stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves, and they're literally the sounds of space ringing. And they will travel out from these black holes at the speed of light as they ring down and coalesce to one spinning, quiet black hole. If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close. As it falls in, it gets faster and it gets louder.
Scientists used to think black holes were immortal, but even these one day die.
Now we're talking about time scales of unimaginable length, quadrillions of years into the future. On that time scale, even the black holes begin to evaporate.
Blending YouTube and the purpose and the images. See, like, this is YouTube, and this is YouTube. It's a documentary.
According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole.
Philosophers and poets have asked that question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice. Trillions upon trillions of years from now.
Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, or whatever, there is still energy, even in the space itself. And this energy, according to Einstein, exerts a push on the universe.
What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe. Almost 3/4 of the matter-energy content of the universe is this dark energy. And we don't know what it is.
Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future.
So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster with time. A runaway universe.
70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen if that energy continues to be there. The universe will become cold and dark and empty. That's the future as it might be. We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins. And that's why we want to know
and study this subject.
Forecast does seem to be for an ever colder, ever empty universe.
There's fish and chips. Like, yeah, we should go and get fish and chips.
But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can concentrate tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe. Facing the depth of everything there is, this perhaps is their only possibility of escape. And this also raises a very intriguing possibility, sheer speculation of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and proliferate child universes. So an evolution may take among universes in the multiverse. Survival of the fittest may take place. So those universes which do not have intelligent life are infertile. They have no children. But those universes that have mild temperatures, stars like us, would create civilizations that could open up child universes, and they would then proliferate.
after an unimaginable length of time, even the black holes will have evaporated and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero. Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and it keeps not happening forever.
Of space, an actual wave on space-time.
I shop online a lot. Until this day, I'm still surprised by how many good tech deals Karma's found for me there. In fact, a couple weeks ago, Karma...
After the initial drawings have been traced out, everyone is colored by hand. It's taken a team of 5, 2 weeks to get to this stage. Now, 500 drawings for the completed sequence go to the rostrum camera. A single frame of film may be composed of several different pictures, each of which may be moving separately from the other parts. Only when the film has been printed will the animator get a really clear idea of how well his cartoon works. Just one mistake at any stage, and the whole scene may have to be filmed again.
Werken wij nog even door of jullie ook afronden?
Ja, it's okay.
A complicated chart details the order the pictures are filmed in and the movements of the camera.
It doesn't matter.
Match the pictures of the sound effects and any voice and music effects, all of which were pre-recorded. On top of all this, optical effects and film experiments have to be synchronized.
Does everybody know like what to prepare for tomorrow?
Yes.
No.
The finished sequence, to which we have added our own sound effects, has taken 21 days to produce, hundreds of times, and last day is 17 seconds. A plane drawn this time by computer. It still has the slightly cold technical quality computer pictures always have up to now, but it does show how effectively a computer can animate. In an artist studio in London, there's a man who has worked on many cartoon films. In a corner of his studio, Stan Hayward is working to realize his idea that one day computers can be used to help make cartoons that retain the personal touch. At a computer terminal, he works out complicated camera movements in seconds that would normally take hours. One day he believes artists could sit at terminals miles apart, even in different countries, and work together on computer cartoons. The script, the drawings, even the music for a complete film would all be coded on punch tape. Meanwhile, an laboratory computer that is normally used to make technical films has been pressed into service to make express cartoons intended purely for entertainment. A special device enables an image drawn by hand to be traced out and fed into the computer, which will do the animation itself.
Yes.
The computer can take two drawings and work out the movements needed in between. And the animator will know almost at once how his ideas are shaping up.
Why?
Once the drawings are fed into the computer, it can speed them up, slow them, enlarge them, or turn them upside down. The dog on a motorbike chasing a cat, but computerized for the first time. Cat and dog animation itself can be coded by the computer and stored on punch
Ik heb wel
tape.
een half jaar geleefd in de Filipijnen van ene zomer. Maar ik heb toen ook wel echt elk
And the
festival
punch tape is transferred to magnetic tape, which in turn provides
dat ook wel echt doen
signals which will operate a film camera.
na 3 keer de set van dezelfde DJ gehoord hebben, zullen dat echt wel. Maar ja, omdat jij in een speciale scene werkt.
The cartoon is recreated onto the face of a cathode ray tube placed directly below the camera. The computer cartoon has the polish of hand-drawn work, and colors filled in, but the timings of the movements are right. Computer images are also printed out on photosensitive paper. When they've been colored and retouched, they'll be ready to be photographed to produce the finished film. The computer can also create visual effects no animator can. These pictures are
Ik in oktober. Ja, en dat is nog en de
Dus altijd heel dynamisch.
Maar nee, die maakt ook ijs. Ik heb dat nu niet naar een scherm gespeeld meer aan het scherm. Doe dat ze door filologie
A computer's ability for experimental movement has hardly been exploited.
Ja, met 10
It can result in the actual creation of
En ze hebben dat ook alleen afgeleverd met de auto van gaan. Dus ik kan het alleen gebruiken als ze aan
Ja.
Maar ja, maar ja, als je die op weet, ja, project voor je van je master zijn, want eigenlijk, ja, dat is waarschijnlijk zo.